Welcome to Unplugged, an IIoT podcast, where we explore the exciting world of industrial Internet of Things and automation. I'm your host, Phil Saboa.
Hey, g'day, Phil, and I'm Ed Fuentes. Well, Phil, today we're quite excited to have Keiran Stokes. He's across from New Zealand. He's the head of technology, and he's the director and head of technology, I should say, for a company called Thread in New Zealand. And today we're going to have a really interesting discussion around data engineering, digital engineering, and how the IIoT and open source software is transforming this field. So thank you, Keiran, for joining us this morning.
No worries. Thanks for having me.
Keiran's expertise spans across multiple industries, from building products, his appliances, utilities, FMCG, where he's driving digital transformation projects and really kind of re-architecting the whole landscape. It's really kind of interesting to see, I guess. Maybe you can give us a bit of an introduction to how you got into the industry. What are you seeing right at this point in time in your career as well?
Yeah, sure. I've had an unorthodox path to where I am. I actually started my career as a control systems engineer, industrial electrician, really. I learned the trade from my dad. He was self-employed and did small to medium automation jobs around Auckland. And, he taught me how to program PLCs and HMIs and how to install them. And yeah, as a kid, it was, a dream apprenticeship, really, especially when you're in that period of your life. You're always asking why. I'm still doing that, to be honest. And to have it as when it's your dad, you don't really care too much when you're going, why? Probably wasn't as beneficial for him as it was for me. But it was a great introduction into the industrial world. Time went on. I had a couple of jobs, and I was a control systems engineer at a fairly large and technical plant in the timber industry. At one point, this was probably about 12 or 13 years ago, and there really was a specific moment, I guess, where my career sort of moved from very much the OT world into more IT and software. And I was the control systems engineer. I was on the engineering team, and my manager at the time, said to me, Keiran, we seem to cop a lot of the slack when there's sort of a lack of production. All eyes are really on engineering because it's the downtime that everybody can see, right? Which I'm sure you're very familiar with. But when I'm looking at the production process, there seems to be a lot of nuance. There's a lot of micro stops. There's a lot of just operating in inconsistent ways and whatnot. And if only we could sort of quantify the loss in those areas. And that was really, I guess, my first introduction into data, right? And what machinery, what data from machinery can actually tell us. And so, on that particular project, I ended up collecting data, trying to, learn about databases, how to sort of move data here and there and whatnot. And it turned out that, that he identified and so that hunch on was really, really big. And so I was very quickly pulled out of control systems, went into the MES, MOM development space. And that was really a pretty big turning point for me. From there, I moved into another company, which was an engineering company in the appliance industry, where we made essentially the production lines that make appliances across China and the US. And literally on, I think it was day one or day two, they sort of said to me, hey, we want to create there's this term industry 4.0. So this is going back, I think it's been about 2013, 2014. There's this term industry 4.0, and we want to create, this software product. We want to create a software product that can go with our production lines and into our factories and be a new sort of revenue stream. And are you interested in taking part in that? And I said, yeah, absolutely, let's go. And so then I guess I got thrusted into, developing a product, right? A software product around industrial data, insights, analytics, software and whatnot. That was a huge learning curve. I actually, funnily enough, used Ignition to sort of do the prototype of that product. It turns out, Ignition isn't the best backend for a software, for actually, an actual software package, as great as it is for sort of industrial data and whatnot, as a framework for actually developing software. It's obviously wasn't designed for that, but I used it as a prototyping mechanism, and that was enough to sort of get funding to then sort of go further and get a proper software team in and get exposed to the IT world, to cloud architecture, all of that good stuff. And really from that point on, my life was very much more IT centric, I guess, but still obviously leaning on a lot of that OT industrial experience that I had. Yeah, and look, 5 years ago, I founded Thread with two others, Bob Vanderkeulen and Hamish Scott. And really the I guess the driver behind Thread was there was still a big gap between the promise of the future, right, of Industry 4 and whatnot, and the reality of the technology that we had available to us. I think we felt this especially in New Zealand, right? So in New Zealand, you have all of the complexity. We have high SKU numbers and manufacturing and whatnot, but we don't have the volume, right? And what that means is you don't have the turnover, right? Doesn't really justify the amount that you had to spend on these licensing costs for whether it's an industrial ID platform or some visualization software, whatever it is. The numbers didn't really add up. And so for us, we sort of looked at, this idea of, you're going to come to work and information will be at your fingertips and everything will be magically connected and so on and so forth. And then looked at, what was on offer in the tech space. And it was a massive gap there. And so we really started the company, not knowing exactly what we were going to build, but just knowing that we were going to do something to try and close that gap. What that ended up being to start off with was really, I guess we built, a platform and framework, data engineering, which we'll go into in a moment, data pipelines and whatnot to really host things for our customers so that we could sort of deliver a much more cost-effective and much more timely solution, right? So take examples that your audience are probably familiar with. You talk about maybe just doing some base metrics for a production line, whether production throughput, OEE, downtime, that kind of thing. Rather than that being, a $50,000 to $100,000 job, we were able to make it more like a $10,000 job, right? And that was good to a certain point, and it's still something that we do on a day-to-day basis. But it's not going to change the industry, right? That's something that we're doing with our customers, and there's still a long sales process, and we're engaged with our customers quite deeply, and it's not going to be anything that's sort of off the shelf. And so for us, we're really looking at that stack that we've now built and going, well, what can we take out of the stack? What's the really difficult part, right? And that's where we sort of landed at the end of last year was building this tool, which is becoming Thread Cloud. It's not out yet, but we're working with a few of our customers who are implementing it, and a few innovators across US and Europe who are getting their hands on it and giving us feedback. And really, what it is a data contextualization tool. So it takes data from your factory, adds context, models it, and really puts it into your IT enterprise data stack, which might be your Snowflake, your Databricks, or your Postgres, whatever it might be, BigQuery, and it takes care of all of the transformations on that IT side. So in a nutshell, that's sort of where I've been and where I'm at now. In a few sentences, I suppose, maybe a few.
Thanks for sharing I guess your journey into automation and how Thread is assisting your customer base with digital tools to be able to enable them to connect their businesses with context, which is pretty cool as well. I guess digital engineering, that seems like a very big and broad kind of topic with lots of nuances. I guess maybe you can kind of dive a little bit into that and kind of go into, I guess, what's the differences in data engineering maybe for IT and for OT, and perhaps how it compares to DataOps, and maybe go into those definitions as well.
Yeah, sure. Definition chat is always really dicey.
That is very true.
You're setting me up here, but no, yeah, it's like I'll give a disclaimer. I'll give my take on these things, which I hope is fairly reasonably well educated. So, I mean, data engineering, put simply, is really the building of systems that, you know, collect, move, store, and transform data into usable data and or insights. The building of data pipelines, essentially, right? And that's been around for as long as databases and having to move data somewhere has been around. Yes, the sophistication levels have changed considerably over the years. Yeah, and there's also a big difference between OT data engineering and IT data engineering. Not a big difference in the sense of what they're trying to achieve. We're still building data pipelines at the end of the day, but the tool set is very different, right? Now, when you talk about DataOps is really that hasn't been around as long. That term feels to me about sort of 10 years-ish. I'm not too sure on exact date or exactly when it was coined and by whom, but what that coincides with is treating data as a product, right? So before DataOps, really, when I'd say a digital product, you'd think of a piece of software, and maybe it was a software that you install on a CD-ROM or your floppy disk, right? And then the web came about, and we had web applications, and software became SaaS, and a product became SaaS, and product became, you know, still the installable software. But at some point, we recognized that data itself should be a product. I mean, there was that famous email by Jeff Bezos, right, in 2007, where he sent out that email to the different departments of Amazon, and saying essentially that treat your data as a product. He didn't use those terms, I don't think, but it was really, you know, the product that I'm delivering is an interface to data and information. And that happened. It happened externally, so in the form of APIs and whatnot. If you go to any platform, Google or Meta or whatever, everybody has an API. But more commonly, I think data as a product acts internally, right? Where you're responsible for providing your data from your domain to your wider business. And when you think of it like that, delivering data as a product, there's a whole lot of other stuff you would expect to be there other than just the data engineering, right? You can go and build a pipeline, but you expect more from a product. You expect reliability. You expect it to be of quality. You expect it to always be there. You expect to, when you are developing that data pipeline or doing that data engineering, I should have version control. I should have more than one person be able to work on that data pipeline, right? That sort of whole culture, framework, those methodologies around providing data as a product is DataOps, right? For whatever reason, in the industrial world, the word DataOps has sort of snuck in earlier than data engineering. I'm not too sure why or how that's happened, but I think when in the industrial world, when people say DataOps, a lot of the time they're just talking about data engineering, and this is the problem with terms, right? Is they over time they get muddy, they get more broad, they fill voids to sort of mean absolutely everything, like Industry 4, like digital transformation and whatnot. But the initial concept of DataOps was that, right? It was really, you know, how do you deliver data as a product? And yeah, but as I say, in the industrial world, you don't hear data engineering too often, yet people are doing it all the time. Ignition's a good example of a tool where you do data engineering, right? I'm taking data from a PLC and I'm putting it into a database. That's essentially data engineering, and that's been happening for years, not just with Ignition and modern industrial IoT platforms, but even just basic SCADA, basic historian, that's been around for decades. That's all just a form of data engineering, and yeah, DataOps is really that more broad scope. Does that? Am I making sense?
No, I think you're right, Keiran. We've seen I love the way you've mentioned the data engineering and data ops are separated, because you're right. Data ops, that's all in many people's vernacular. That's what data ops is includes the connection of getting that data from whatever source it is into an environment, and then talking about taking that data and doing something with it, which is that ops part, I suppose. And there are two parts of that segment. In your journey, Keiran, when you're talking about data engineering, what are some of the hardest things in data engineering? Where are the challenges? Because you talked about the small companies, that mini SKUs, low volume. They've got challenges themselves, so they sort of maybe are, I wouldn't say afraid, but challenged to move to a digital landscape. Let's call it. Why is it hard? What's happened?
Yeah, it's quite a beefy list. Yeah, look, I think we in industry we suffer these challenges harder than in sort of the pure IT world. In IT only, things already set up for you, kind of thing, right? So databases are a given. Like when you're just systems to systems in a cloud environment, things are fairly simple from a data integration point of view. Maybe not easy, but easier. You go to the industrial world, and all the listeners of this podcast are going to know all of these things, right? It's like there's just stuff everywhere, and it's all sorts. It's the Wild West, right? I've got a CMMS over here, and then I've got some Excel report that someone built over here that's now become not just a report but an application because it's got some macros running in it, and then I've got some quality system over there that was built in the 90s, and then I've got PLCs, I've got barcode readers, I've got printers, I've got all of this stuff. And that challenge is just much bigger, right? Because of all of these sort of siloed disparate systems. On top of that, none of those systems in the industrial space, most of those systems don't have the incentive to share their data and interface with other systems, right? In the IT world, they are. I mean, that's what information technology. The whole premise is information, right? It's moving data and information around. So there's this sort of unspoken understanding that whatever you're doing is probably going to be interfaced with from an information point of view. In the industrial world, it's more about command and control. Operational technology. It's operations. It's doing stuff. So the idea of moving data and information isn't a given, right? So that I would add to the complexity. So that yes, there's lots of different systems, but also those systems aren't usually set up to exchange data and information. So yeah, those to me would probably be the standout reasons as to why it's particularly difficult. On top of that, you've also got the concept of the phenomenon of domain knowledge, right? And understanding what it is you're actually interfacing with. It's a bit of a fallacy that you can have a data team of data engineers come from outside of the industrial domain and do data engineering in industry. It doesn't really work, right? Because again, these systems, because they're not designed to share information, you've got to understand what they are before you're able to actually help them to share information and exchange data. So it's also a resourcing thing, I think, is a big problem. There's just not a lot of data engineers in the industrial space. Hence, I mean, like I said, the term's not even really used. If you go onto your local job site, you're a data engineer.
No.
In IT world, you get heaps of listings. There's such a common role. Oh, data engineer. You go into the OT space, there's nothing. It's control systems engineers, SCADA engineers. You got this concept of this industry 4 engineer coming out now, but it's not like a really rich sort of role, understood space. Yet everyone's sort of doing it, but not.
Yeah, I guess context is quite a weave of information, right? It's this journey from the raw data point that you're collecting, and then all those connections around that data point. And then it grows even further still because you've got these siloed operations, which maybe they have a connection to, down the track. Maybe it's part of a recipe, or if it's part, it's impacting a production schedule, or it's, this huge wave of data that is not contextualized. It's just raw data being piped into whatever. Talked about data pipelines, pushing it into a database and creating this bigger data set that you don't understand what the context is. I guess Thread is known for some of its innovative products, and one of the topics we've talked about in the past is these knowledge graphs. I guess could you explain to listeners around Thread's use of knowledge graphs and how it kind of reflects in that data engineering space and actually contextualizing that data.
Yeah. So going on for another definition. Yeah, this is a yeah. So knowledge graph. I guess first to talk about what that is. Knowledge graph. I'll start off by saying that it is the worst term to describe what a knowledge graph is if you don't know what a knowledge graph is, right? It's awful, right? So when people think about graphs, they think about charts, bar charts or line charts, whatever it might be. But knowledge graph in this term is the mathematical definition of graph, right? The data structure of nodes and relationships. So a knowledge graph is a way of representing entities with multiple relationships. It's best thought of as like a web of knowledge or a map of information, right? And that's opposed to hierarchical data structure, right? Which is what, if you go into your computer, if you're on your computer right now, go into your documents and you see folders or a tag tree in your in Ignition or whatever OT platform you're using. It's folders within folders and data points, tags within those folders, right? Now, the problem with hierarchies is you can only really define one linear form of context, right? So all I know from a contextual point of view, from a relationship point of view to the other stuff amongst this data structure is what is my parent and what are my siblings, right? So I know what's in this folder and I know what's above me. I don't really know anything more than that. So with a knowledge graph, you've got more flexibility. You can have relationships to things in other folders, right? And you can have relationships to your parent, but also to other parents. I mean, depending on what that relationship might be. And what's funny is, I mean, when you think about the industrial world and you think about all of the tags and data points out in the field, and Phil, you just had a bit of a spiel there of this connected to that and that connected to this, and it's much better represented as a knowledge graph than as a hierarchy. But we're so used to seeing hierarchies. It's the way this industry is really developed. I mean, from a PLC and SCADA point of view, you can sort of see how it happens. At the end of the day, you're not really caring about context when you're just making a conveyor move or something, right? It's I've got my folders and maybe I've gone by line and by machine, ISA 95 kind of structure and whatnot, and I've got my data points there and I can do my programming, I can write my code, and okay, I'm good, right? But then when you want to use that from an information point of view and capture context around all that, those data points and folders, it doesn't exist, right? So at Thread, we use knowledge graphs essentially to store context. Getting again into another definition, right? Context is another thing that I think is maybe a little misunderstood or underappreciated in industry. So context isn't just descriptive metadata. It's not just, this is where this sensor is located and it has this model number sensor on it, and it's brown, or whatever. Like these sort of just descriptive elements to it is a lot of the time what people think when they think of context. But that's sort of one bucket of context. We like to say that a context is really, what does a data point, what is it? So that's your descriptive metadata. What does it do? And what is it related to? So, what does it do? It's like, well, what process is this thing involved with, and what does it contribute to that process? And what is it related to as well? Is it influenced by this? Is it influenced by that? There's a whole raft of things you can talk about when it comes to relationships. So we take all of that context. We create a system essentially, which is based on a knowledge graph. And this is actually part of what Thread Cloud, the product, is. It's a knowledge graph that allows you to capture all of that context and codify, most importantly, those relationships. Now, next, the following question might be, well, why is that context that important? It turns out the more complex you go down the data analytics and insights path, the more context you need, and the more insights you're actually able to make. The other, I guess, more lofty thing and topical thing at the moment is the role of LLMs. Now, I'm a skeptic as well as a supporter. I don't think LLMs are perhaps as revolutionary as what they're being made out to be. But what they are really useful for in the data and information space is understanding about your data, right? And about that knowledge graph and the structure, knowing how my data and information is structured, right? So if you think of being, again, coming from another world, like I'm working in some other company and I get thrusted into a manufacturing environment, and it's the first time I've been in factory A producing, X products, whatever they happen to be, and I don't know much about the process. I don't know much about anything. A knowledge graph combined with LLMs is really powerful there, right? Because I can actually ask questions about the data that I want to do my analysis on. It's probably not going to come up with the insights, so it's not going to, we're not at the point yet where I can walk into work and go, hey, just tell me what improvement actions to make on my production line right now. And it's able to give me some engineering task to go ahead and do based on all the data that's collected. So we're far away from that point. But where we are at is actually just using it as a tool for understanding that web of knowledge about your data and information a lot better.
Your journey, I'm taking your stories here with the context, again, the word context, about how the challenge you're facing, having lots of manufacturers with small amount of like high SKUs, low volume, and you're trying to hit this price point. You mentioned if they do things like metrics, it's quite expensive, but we want to get down to this price point, which can basically touch as many manufacturers in your space as much as you can. And I'm assuming that's what's driven the knowledge products and your Thread Cloud, is to make it easier. Well, let's say easier, because there are challenges still. Even as much as we make the technology or the data engineering as quick, easy as possible, there's still that integration part. In that journey, Keiran, trying to get there, I'm assuming you're probably using some open source software. Is that helping data engineering? Is that helping shape the future of how customers are, or how you are adopting potentially this technology to help your customers gain better insight?
Yeah, of course. Open source plays a big role internally to our company, and we leverage a lot of open source technology. To speak briefly about open source in general, kind of open source supporters that everything should be open source and the world would be a great place. I think that's very idealistic, and I don't think that's going to happen. There's a lot. What open source is really good for is it's really like the market wish list, right? And it very much puts pressure on the incumbents to really create what the market wants. And you guys are really familiar, I know, offline with open source tools and the home automation that you comment a lot on, Phil, and whatnot. And there's so much out there to sort of play and experiment with data engineering to get a good feel for it, to understand it and whatnot, which is all really beneficial. From our point of view, there's a lot of open source software out there that's actually really robust, really reliable, that we use to build and provide our products and services. That's where I think open source is it really comes to the forefront, right? Is to actually allow commercial companies to utilize that and bring their products at a lower cost to the market, right? And that that also just brings up the point that it's more than just when you provide a product to a customer, you're always going to be providing more than just the software, right? The product's not just the software, whereas open source is just the software, right? Whereas we can combine things like infrastructure and hosting and support and all of those that good stuff. So a lot of the good companies for me at the moment, when I look around the space and a lot of the companies that we use, are open source technology being commercialized. So You look at Timescale, we're a customer of Timescale Cloud. Again, open source technology being provided in a commercial model. Portainer, another great company. DBT, we use a lot of. They're all open source, but they're all commercialized open source. So yeah, open source is getting bigger and bigger. It's exciting because it's really speeding innovation along. And as I say, it's putting pressure on the incumbents to actually, if they're not going to do what the market needs, somebody will. And yeah, it really acts as, I think, the catalyst for the market.
Yeah, it's really driving that kind of innovation space, right? And rapidly being able to be deployed in a commercial environment, having that code base to kind of give you that first step on the rung. Of course, you have to support it, which is a kind of a challenge, right, for most commercial type products, is that you're building on a kind of pre-developed framework that then you have to manipulate or update or support moving forward. So it gives you that kind of first step in that software development process, but then you have to enhance it and build value on top of it.
Absolutely. And that plays straight into those, as I say, those those companies that are providing that support around. A lot of the time you'll start by playing with the open source, like you said, and then go, and this company happens to be commercializing and providing all the peripheral stuff around the piece of software, like the support and the reliability and all that kind of good stuff. So therefore, it's less of a risk for me now to say, I'm going to go with that company as my provider because I've already done all the testing and prototyping, as you say.
Yeah. And a lot of commercial kind of products are born from that open source space so that they can, they give everyone the opportunity to leverage what they've developed in the first case and then have commercial support mechanisms, like scalability, right, is one thing, right? We've seen the adoption of Node-RED with then the adoption of Flowfuse to manage those Node-RED instances. And same with Grafana, right? Grafana being taken on and then having the commercial partnership to be able to take that further. And all these different platforms kind of have that, open source at heart and then leverage that community to be able to create commercial products and support the development of those open source products as well. It's pretty interesting space, that open source community, and how it's moving forward as well. I guess we talk about a lot of different, technology stacks on this podcast, and something that's, we've mentioned AI, and I guess talking about, what's the next step? Is it digital twins? How does this information structure come into that picture? I guess, what's your definition of a digital twin? We've talked about definitions here. I'd like to hear a bit more about yours. Throw another one out there. We're doing definitions today, so we might as well.
Yeah. Digital twin's a funny one. It's back in so I think it was 2016 or 2017. I presented at Hannover Messe, right, and over in Germany, a big trade show, which I'm sure many listeners are familiar with. And when we got there, digital twin was everywhere. Like every second stand, it was just like digital twin. Much like I hear UNS was this year. And we actually had a stand within a stand. So I was on the Hire, who were a conglomerate, appliance, still are, appliance company from China. We had a stand on their booth, and we were next to a Cobot company, and they had one on display. And we were demonstrating an Industry 4.0 SaaS software product, web development, web application. And when we got there and we were doing the setup, I was talking to the guy with the Cobot, and we're sort of chatting, and he mentioned that, just when we're getting into the weeds a bit on the technical side, he said, this thing can actually emit its position, in real time MQTT, export the position of the three axes out. And that's quite interesting. I wonder if we could replicate the Cobot. We're next to you on your stand. We'll embed a picture, like a video of that Cobot, and show it in our web application in real time, right? Following the following the Cobot. And luckily we had the Europe, New Zealand time. So I got on the phone to the developers back in NZ, and they started creating this thing, right? And so we had on like through day one, at some point, we had this thing come live, which was this digital replica of this Cobot. And we thought, sweet, we're getting on the digital twin. We didn't bring our digital twin poster, so we've got this instead, And yeah, it was cool. Got some good reactions. But when you think about it, it's like, what's that good for? Probably absolutely nothing, apart from if you're going to go to Hanover and you want to show off some 3D visualization in your web application. And I think this gets at the heart of what I don't like about digital twin, which is like when people start with it. It's like if you're doing a project that's called the digital twin project, you probably want to just reassess what one is doing, right? Because it needs to be a means to an end, not the end of what you're actually targeting. So but is simulation valuable? Yeah, of course. Like, of course it is. Like, if I'm wanting to do more efficient production planning, if I'm wanting to, do sort of product design for manufacturing and understand how that's gonna change if I change this variable and that variable. Yeah, absolutely. It's going to be very valuable. It's also very valuable from just machine learning points of view and predictive analytics and whatnot. But you need to start with that business case first, rather than starting with the fact that you're going to build a digital twin, because a digital twin may or may not be needed for what it is that you want to do. And I think a lot of people just get that in reverse. And I think that's sort of why it hasn't fizzled out completely, but it's certainly since, like I said, that was 2000, I can't remember, it was 16 or 17, but I think it was 17. The 2017, and we're in 2024 now. It's definitely depleted a lot since then.
Yeah, I think we tend to go through phases in the industrial space pretty quick, within 12 months, 24 months, right? Usually, whatever the hot topic is, whether it's AI, cobots, and we want innovation and we want it now. That kind of approach, I guess.
And marketers have to have a job, don't they? So,
well, it's interesting because manufacturing is suffering challenges in every aspect, from competition, cost of production, resourcing, supply chain. I'm sure I can rattle off many, many things, and we play in a very narrow space in that space. Well, we all do that with industrial automation. We're focusing on the OT layer particularly, and when you see these manufacturers, I suppose, Keiran, in your experience, the journey you've gone through, and you're watching your passion around data engineering and getting that first step is, maybe let me go back and ask this question: what is the first step look like for a manufacturer who's knows they have to do something? They go to the shows, they go to the events, they hear the stories. What do you, in your experience, or what should they be doing as the first step?
Yeah, that's a good question, and I'm gonna let the team down and give a very non-technical answer here. You need to start by identifying the question that you're trying to answer from a business point of view. Too often we push technology into businesses before pulling it into businesses, right? And really, there's going to be some reason why you need data engineering. You're going to want to answer some question, right? Essentially, that's what we're all in the business of, is answering questions faster and in a smart way. And in order to do that, you often need data and information. And depending on the question will depend on the data and information that you need. Now, I'm not saying that you want to, it doesn't matter how you do the tech or whatnot. I'm definitely not saying that at all. You definitely want to have sort of strategy and really sound architecture principles and fundamentals around the technology that you're putting in and how you're actually going to do the data engineering. But it has to start with the desire to want to answer some question, right? Or make some improvement somewhere. So first point for me is always, identifying what that is. And it may be pretty basic to start off with. I mean, it's amazing how many manufacturers don't really truly understand just how well they're operating, like at a really basic level,
Okay.
right? It's like you might know sort of what your output is, you know what your quality rates are usually, you might know what your major downtime is, but other than that, a lot of manufacturers don't really understand the nuance of their operations and actually how well they are operating. So that is often a first start for us, is actually in those sort of base metrics, really understanding at a granular level how production machinery is operating and how efficient it is. You'll probably notice I'm purposely avoiding the word OEE for a myriad of reasons, but I think again, there's so many places I go into where OEE is not OEE, and they're just measuring it wrong. And I think what's more important is, do you understand where your loss is, and do you understand how to close the gap? That's the most important thing. Whatever language you sort of put around that and sort of how you do those metrics, OEE eventually always comes, right? I think when you reach a certain level of maturity, but the first port of call is understand your process, understand the gap, and understand how to start closing that gap.
I find that it's sometimes I struggle with the right questions to ask, because I imagine the people on the floor, they know they can probably point to all the things that are going wrong, things we can improve on, but they're not the people with the money sometimes. And it's getting to the right level of the business, like you mentioned, who understands what their process is and what is the right question to ask, so they can find and then talk to people like you. Or do you help them in that space of asking the right questions?
Yeah, we do help in asking those right questions, but really, if you take a Socratic approach to it, right, and you really just dig on why they're trying to answer that, why you're trying to answer that, and you really get to the heart of it, you do end up with these sort of fundamental metrics that they just don't have, and that's why they're asking the question in the first place. And it's going back to first principles and really building from that ground up. You mentioned the operators there, sort of having that anecdotal evidence of what's wrong and what needs improving, always really handy to lean on. In fact, I lean on operators a lot. What operators don't have is the validation of what they know. They don't have the numbers. They don't have the quantification to say. So they'll go, oh, you know what the problem is? It's X. That's what the problem is. And then when they're asked by managers, well, how much of a problem is it? Oh, it's just really annoying. It stops me heaps. It's not. They're not able to sort of articulate these really sharp numbers on it's costing you this amount every single month, this amount every year. And so a lot of what we do is that, right? Is really just putting some hard numbers to what a lot of people already know or already think. But you have to have hard numbers in order to prioritize, right? In order to actually rank in what order you're going to attack things. Most people aren't short of all of the things that they want to do. They're not short of the problems that they want to solve. What they're short of is the information to make the right decision on which problem to attack and in which order. And so we help with a lot of getting that data.
Yeah, that's a really key takeaway there about, identifying, okay, what is the motivation for collecting this data in the first place, right? It is to shorten that discovery of the root cause analysis, right? At the end of the day, you want to be able to solve that problem that you're facing, even though you don't know about it at the time, right? You want to go, okay, we actually needed to tighten the tension on that belt, or we actually needed to stop Joe Bloggs going on lunch at this time. He needs to now take it at this time, because we can see that there's a coalescence between the data streams there. Unfortunately, Mr. Joe, you're going to have a shorter break in that time. Sorry, mate, as well. I guess as we start to wrap up the podcast, we always ask our guests. I guess me and Ed, we're on our learning journeys. I guess what's new for Keiran? What are you focusing on your next kind of learning point in this space?
That's the reason that's difficult to answer is because I just feel like I'm like you guys. I'm just constantly learning all the time. And so, yeah, my focus really just drifts on whatever happens to be the most important thing that I happen to be working with. So it's really anything and everything for me. I guess a lot of my focus is on the adoption of technology. Like I'm very interested, I guess, in the psyche of sort of how decisions are made and why particular products, and if they pitched in this way, they're sort of getting a lot of motion, get a lot of runs on the board, where this product isn't. But why isn't that getting picked up? Because it's got all of the technology sort of things that we want in that product. Why isn't that taking off? That kind of stuff I find really interesting. It's not really something you can Google, unfortunately. It's sort of something you got to just ponder on and sort of learn with experience. But like all of the common stuff, I'm always data engineering and I'm always obviously thinking about that a lot, and all of the trends there. I think in industry, to pick a couple that I'd say are going to be the next big thing in industry, I think data quality is a big one. Data observability, being able to sort of detect anomalies across industrial data, I think is going to come to the forefront. I think just to touch back, and obviously we are wrapping up, right? And to circle back to DataOps and why that isn't a bigger thing when talking about that definition I originally spoke about, which is, data as a product. I really would love to see data as a product in industry treated a bit more, taken a bit more seriously, right? This whole, working on a production environment, unable to sort of simulate test data and data pipelines breaking in industry for some reason seems to be a lot more acceptable than on the IT side. We sort of go, oh yeah, it's just the way it is. It's like, if you've got your Wonderware or your Ignition or your ThingWorks, it's like generally you only have one instance. There's very little staging environments. Some customers are doing that, not very many. I'd love to see that become more prevalent. So yeah, that DataOps space to me is really a really interesting space too, and in the industrial world. So that's definitely one I'll keep trying to grow in and keep learning about.
Keiran, thank you for sharing your insights today on how, we're using these technologies, how there's a lot of people behind those processes and technologies as well, and getting a better understanding of what data is and how it's structured and all these different, connectivity challenges around that. It was really interesting how you're kind of tackling that data engineering space as well.
Oh, Keiran, it was really good. Actually, we're going to need Keiran back on again. I've got so many more questions to ask, and I know we're out of time. But I really want to dive deeper down into that. I love the idea of the psyche you talked about, Keiran. That thought process as to why, I wanted to go talk about the push. When you're sick, you go to see a doctor. I want to get these manufacturers thinking, hey, well, I need to be better. What do I do? So I definitely want to go down that area. I think you've got some excellent insights. I love the definitions you've put together for us today. It really helped me understand as well. I really got a real high appreciation around data engineering as it plays into that whole data ops psyche. So thank you so much for what you're doing, your contribution as well. That's been fantastic. So thank you very much, Keiran, for being with us today.
No, thank you guys. Yeah, we'd love to do it again sometime.
No, it'd be really great to have you. So for our listeners, don't forget to subscribe to Unplugged, an IIoT podcast, for more episodes and industry leaders and innovators just like Keiran. Thanks for tuning in, and we'll see you next time.